Today I'm going to show you why f of gx and g of f of gx and g of fx can give completely different answers even though they use the same two functions. This single mistake costs students marks every year. In the previous lesson, we did function notations, we did notations, we did domain, we did range, we did mappings, and the lecture you can find in our playlist on our YouTube on this very channel. So if I tell you, what does this mean? F of 3 equal to 7. Now what has happened here? So this means that an input of x is equal to 3, or the input variable 3 was entered and an output of 7 came out. Today we are going to send outputs into other functions. Now, using the same machine idea that we did in the first lesson, what does f of gx mean? So this means that the input x was first used as a rule into g of x, and then this g of x was applied the rule f in order to produce the output f of gx. So basically x was applied gx in order to produce a gx, and then it was applied f of x in order to produce f of g of x. Okay, so that's the entire idea. So this means that gx first, then fx second, and order matters, here order really matters. So what are we saying? Let me reiterate it. So first of all, this this x is going to act, the g is going to act on x, and then f is going to act on this entire gx in order to produce your final output. Let's say, as an example, you have got these two functions, g of x is equal to 3x and f of x is equal to x minus 7. If we were to find out f of gx, then what's going to happen? First of all, gx first. So we are going to write that g of x is equal to 3x, and now f is going to apply on g of x in order to produce f of gx. So now instead of x here, so if we have f of x is equal to x minus 7, then instead of x, so when we apply g of x, so this is nothing but g of x, which is 3x. So we are going to apply 3x in place of x. So this is going to become 3 of x minus 7. So f of g of x is going to be 3x minus 7. Again, the inside function goes first. Now I'll ask you to pause this video and try to find these two, f of gx and g of fx. You can pause it and I'll proceed to solving it. Now f of gx is going to be, so in f of x, which is 2x minus 5, you are going to put gx as input. So I will write, in place of x, I will write g of x, and g of x is nothing but 3x minus 1 minus 5. So f of gx is going to become 6x minus 2 minus 7 is 6x minus 7. So f of gx is going to be 6x minus 7. Now I'll change color. In order to find g of x, now fx is going to serve as input for this, is going to serve as input for g of x. Okay, so g of x is 3x minus 1, and now when f of x acts as an input in the g rule, so 3 times f of x minus 1, and now f of x is nothing but 2x minus 5, and then minus 1 gets copied here as it is. So this becomes 6x minus 15 minus 1 is minus 16. So this is g of fx. Now you can clearly see that here in this function, f of gx is not at all equal to g of fx, and do not make this mistake. A lot of students does this, and Cambridge has been reiterating this mention repeatedly in all their examiner reports almost every year. Now what if you were given a function f of x is equal to 2x plus 3, and you were asked to find out f square of x. Now f square of x is simply f applying on itself twice. Okay, so this means that so we had f of x is equal to 2x plus 3. Now f of fx is 2 of fx plus 3, and instead in place of fx, so this fx is same as this fx, so I will just put this in here. So this becomes 2 of 2x plus 3, and then this gets copied here as it is, so plus 3. So this becomes 6x plus 6 plus 3 is 6x plus 9. So this is your f of fx. So f was applied twice. Now I want you guys to pause the video and try to work through example number 4 and find out f of gx, g of fx, and f of fx. Okay, now you can pause the video and I'll proceed to solve it. Now in order to find the first one, which is f of gx, so this is going to be nothing but, so f of x is going to be 2x plus 3. Now in place of x, I'm going to put the input gx function. So this is going to be 2 of gx plus 3. Now gx is nothing but x squared minus 1. So this is x squared minus 1 plus 3. So our f of gx is going to be nothing but 2x squared minus 2 plus 3 is 2x squared plus 1. So that's going to be my answer for f of gx. I'm going to put a bracket around it. Now let's do g of x with another color. Now g of x is x squared minus 1. Now in place of x, if I have to input the function f of x, I can do exactly that. So in place of x, I will put fx, and make sure that you are not forgetting this power. Okay, so this is x squared and then minus 1. So f of x is nothing but 2x plus 3, and this is a squared and then negative 1. Now apply a plus b whole square. So this becomes 4x squared plus 12x plus 9 minus 1 is plus 8. So this is going to be my g of fx, and I'm going to put a square around it. You can copy it, and then I'll proceed to doing the last part. I hope the answers are matching. Now let's do the final bit. If I have to find out f of fx, right? Now I know that f of x is equal to 2x plus 3. So if I put the function itself as an input, so this becomes 2 of fx plus 3. So this is 2 of fx is nothing but this 2x plus 3, and then plus 3 gets copied from the previous step. So this is 4x plus 6 plus 3 is 4x plus 9, and this is my f squared x, or f of fx. So this is the heart of composite functions. So if you are getting it till here, I think you are going to do just fine in this topic. Now this example number 5 is from our Insta stories that I posted today on our channel Easy Talim. I've put the handle here as well, Easy, EASY, Talim, TALEEM. So let's say fx is equal to x squared plus 4x, and gx is 3x minus 1. We have to find values of k for which this function, composite function f gx equal to k, only has one solution. So now the hint directly is that the discriminant of this function, once we equate f gx to k, only provides a single solution, and the discriminant is equal to 0, right? So the third value inside the quadratic formula is 0, right? We will cover this discriminant part in a lot more detail in next week when we do quadratics on this very channel. Now let's proceed to do this. Now first of all, let's set up this equation f of gx is equal to k. Now f of x is nothing but x squared plus 4x. Now we have to input gx in this function, so make sure that you are applying it here and here both. Applying it here and here both. Okay, now so this is fx whole squared plus 4 times f of x. Now this is g of x, my bad, and this is also g of x. So now g of x is nothing but 3x minus 1 whole squared. plus 4 times 3x minus 1. Now we are going to expand it. So this is nothing but 3x squared minus 6x plus 1 plus 12x minus 4. So simplified form is going to be plus 6x minus 3. So this is f of gx, and we are told that this is equal to k. Now, and this expression, this entire expression only has a single root, right? Which means that its discriminant is going to be equal to 0. Now, this is going, let me change color. So this is going to be 9x squared plus 6x minus 3 minus k, or I can put a plus here and put it inside the bracket, is equal to 0. Now, this 9 is my A, this 6 is my B, and this minus 3 minus K is my C, and I can put it in my discriminant formula, which is B squared minus 4AC, and since there is only one solution, so this is equal to 0. So now B squared is 36 minus 4, A is 9, C is minus 3 minus K, or I can put plus 3 plus K and send the minus here and equate it to 0. So this becomes 36 equal to negative 36 and 3 plus k. So now I divide both the sides by negative 36. So this is negative 1 equals to 3 plus k. So k is going to be equal to negative 4, and that's the only value. So these type of extension of this topic comes in your exams. So I hope this question is clear for everyone. In the case that this question stated that for which f of gx is equal to k has real solutions. Now, real solution mean that it may be one solution or it may be two solutions, in which case it would be greater than 0. So you would set up your discriminant as greater than 0, and in this part you would have gotten your answer as k is greater than and equal to negative 4. However, the question did not ask us that, or if in case it asked us that had no real solutions, then you would set up your discriminant as less than 0, and in that case, once you would have simplified it, you would have gotten your answer as k is going to be less than minus 4. Okay. Now there are 3 exam rules for composite functions. So 3 exam rules. So number 1, work from inside out. So if this is f of gx, then you are first going to do g of x and then going to put it into the f rule. So this is going to become x applied g in order to give you g of x, then applied f in order to give you f of g of x. Rule number 2 is, and I'm going to change color, rule number 2 is that f of gx may be in some cases equal to g of x, but usually it's not a condition that they both should be equal to each other. So it's not they are not equal to each other in general. Okay, so in general they are not equal to each other. Okay, now rule number 3 is going to be, you have to check the domain restrictions. Check domain restrictions. I hope you guys are. If I'm talking too fast, you are following through the subtitles, or you are pausing it or repeating the video in order to, and in making sure that you are putting everything down in your notebook. Okay. Now, composite functions work only when outputs from the first function, so the range of the first function, are allowed inputs into the second function. So in this one, so f's domain will overlap or must overlap with g's range. Okay, and I'll explain it to you in the later videos. Okay, now in the next lecture, what we are going to do is we are going to do inverse function, where students are going to learn what does this f inverse of x mean, how do we switch the domain and range when we are swapping the y values with x values, because the inverse function is nothing but a reflection on the y-axis, y equal to x line. Y inverse functions undo a function, which means that if you apply f of x on f of of fx, this is going to produce an x, and how composite functions make inverse functions easy, right? So we are going to do that. If you have any queries, you can DM me or reach out to me on WhatsApp at +92 329 3028 485. And you should also follow us on Instagram, and we go by the handle Easy Talim, TALEEM. Now I'm going to see you in the next video day after.